Hey everyone, I'm Xinglu. I'm a product manager at Boundary. Today we're just going to go over, a quick overview of Boundary for those that aren't as familiar or just want a quick refresher. And then we'll talk about 4 of the new features out of many in the latest 0.12 release. And those are going to be multi-hop sessions, signed SSH certificate injection, approvals workflow with indent, and supporting addresses directly on targets. So if you're not familiar with Boundary, basically Boundary is our secure access management solution for dynamic infrastructures. So in Boundary, really it's made for that human-to-machine access workflow. So with Boundary, the user can authenticate and authorize into the system with the trusted identity provider, discover and connect to different service registries and resources, and have access to those remote systems, hosts, or services with just-in-time credentials. And the problem we're trying to solve with Boundary is with the traditional access workflow. So just for example, if you have a user in your organization that wants to connect to some VM in a private network, most likely they're going to be connecting through a VPN or SSH fashion. And with that already, the user has access to the entire network, which poses risks because they can access other machines that the administrator might not want them to. With firewall rules, everything is based on IP addresses. So when there's new resources or new users, the administrators will always have to manually go in and update those to keep it up to date and consistent. With privileged access management, there's a large burden on maintaining access controls and again, going in every time manually to edit rules and access permissions for specific individuals. And finally, if your user is connecting to applications with static credentials, there's a high risk of those credentials being exposed and the system getting hacked. With Boundary, we're trying to solve all this with what we call a dynamic access workflow. So with Boundary, the user can log in with a trusted identity provider. Right now, today in Boundary, that is OIDC providers, which makes onboarding and offboarding of all of our users super easy since they'll be already using them within the company. Authorization is based on roles and services, and the users are assigned these roles beforehand, and you can have multiple users and groups given those roles, and those roles can perform the same functions, again, on a specific set within Boundary. The user can select a host or service that they want to connect to, and once that selection is made, if they have access to it, if they're allowed access to it, then they'll only have access to that. They won't have access to anything else within the network still. And finally, with automation and tools such as our Vault integration, users can connect automatically and securely without credentials being exposed. So again, a quick recap on some of the new features in Boundary 0.12. We have multi-hop sessions, which allows users to access remote targets with strict network policies or complex network topologies. SSH certificate injection, which ups the level of security for SSH secrets management within Boundary. Approvals, workflows, integration. So having a way to provide just-in-time approval for remote users that typically don't have access to a specific host or target. And finally, addresses on targets, simplifying that configuration of Boundary for the administrators. I will now pass it on to Van to talk about multi-hop sessions.
Very cool. Thanks, Xinglu. Thank you, Bria, as well for the introduction. Hello, everyone. So I'm going to talk about multi-hop sessions. So we'll kick off the very first topic here. Oh, let me take the screen. We rehearsed this a billion times, and I still did not do it correctly. Okay, so you should see my screen now. All right, so as Xinglu mentioned, Xinglu gave you a nice overview of some of the capabilities of Boundary. I'm gonna dive a little bit deeper, and before I get into the multi-hop session, I figured let's give a quick overview of how things work with Boundary, just for some of the newer folks and just as a refresher as well. So if you are using Boundary, you're a remote user, for example, you would have a Boundary client installed onto your laptop, your desktop, and you want to connect to, say, a resource within your company or your organization's network, say, a Linux host via SSH, or a Windows host via RDP, database, or Kubernetes cluster using kubectl. So to do that with Boundary, typically you'd have your client connect to the Boundary controller to authenticate itself so that you can log into Boundary. And as Xinglu mentioned, you can use your organization's favorite identity provider, Ping, Okta, Auth0. And once you are authenticated, you'll be given a list of hosts or list of targets that you're allowed to connect to. This is done by your administrator. And so that gives you authorization to connect to certain targets. So you pick from that list, you say, hey, I wanted to connect to this target A. In this example, target A is this Linux host. So then the Boundary controller would come back and say, okay, you are allowed. So here's the Boundary worker that you should connect to. This is now the data plane, right? So the Boundary client would be proxied through this Boundary worker that resides in your organization's network, and then connect you and proxy you through all the way to the host. And I didn't mention the secret management part as well. Like there are ways for us to grab secrets and store secrets, store credentials, and then provide it to you, or directly inject them into the host as part of this whole workflow. But I'm simplifying it a little bit, but in general, that's how it works for you to connect in. So this works well for most organizations, but there is a challenge to this, or some things that you have to be aware of, which is this Boundary worker. In order for your Boundary client to connect to this Boundary worker that resides inside of your network, the user needs to have a VPN access to get into that network in the first place, right? Or there needs to be some other ways for that Boundary worker to be accessed from the outside world. So perhaps there's a public IP address that the Boundary client can use to connect to that worker in order to get proxied all the way through, right? So some organizations may not allow this. It could be limiting for some organizations. There are other organizations that have more complex networks as well, where maybe they do allow the client to connect to the Boundary worker through some type of DMZ or some type of public network that is accessible from the outside world, but then all their resources are connected all the resources reside in some other private network that provides outbound access only, or some other complex topology that requires them to hop through different subnets or different networks, right? So there's lots of diverse topologies out there. And so in this example, again, if it's outbound only, then there's no way for that Boundary worker to get into this private network to proxy that connection through to the end host or the end resource. So what do we do? Well, that's why in the latest Boundary .12 GA release, we've addressed these type of complex networks and restrictions that some organizations have, where we take that worker that I just showed you and we break it up into two types, and we allow you to connect and chain these different workers together across these different networks. So, for example, we have the workers broken out to either egress or ingress worker, or egress worker, or both. So a simple example is if you have an ingress worker, the ingress worker has or is able to be connected from the outside world by a client, right? There's access into this ingress worker, and this ingress worker also has access into the general network. That's how it's really defined. We also have a egress worker, and this egress worker is really defined by the fact that it has access to the host. It can connect or is able to route to your host resources, whether that's, again, databases or Linux, Windows, your Kubernetes clusters, right? So from there on out, you can then chain these egress workers and ingress workers together, because the egress worker would make an outbound connection to the ingress worker, to then form the end-to-end connection, right? So that's why we call it multi-hop, right? Or multi-hop sessions or multi-hop workers, as you may hear. And it doesn't have to be two. You can have multiple different workers as well, not just, you're not limited just to one egress and one ingress, right? Because we want to address multiple type of diverse networks. So that's kind of the general concept. And here's how it looks like going back to our example. If you have just a normal customer network where you do allow inbound access and that worker is able to connect to your host resources in the same network, then that's fine. That worker can act as an ingress worker and an egress worker at the same time. So that's pretty simple, just like before. And if you have, say, a little bit more complex of network where you have a public network that is accessible from the outside world, but then a private network that has outbound only, then what you would do is you'd have this ingress worker. Again, this ingress worker is accessible by the boundary client. Then you have the egress worker that can connect to and can access your resources within your infrastructure, right? And then that egress worker will make a connection to the ingress worker. It'll form a persistent connection. So now traffic can flow both ways. And then the boundary client can simply get proxied through to the ingress worker, through the egress worker, and finally to the final destination, which is your host resource. And what if you have a really strict network where they only allow outbound access throughout the whole organization? There's not even a concept of an inbound access at all, right? It's super strict. So in that sense, you still have your egress worker, but without a public network, what you can use is HashiCorp's own network. So we provide, out of the box, we provide HCP workers. So when you deploy Boundary, we automatically deploy these HCP workers that reside in our network. And these HCP workers can act as an ingress worker on behalf of your organization. So what happens is your Boundary client would, going back one step, the egress worker would connect to this HCP Boundary worker, right? And the same concept applies. It forms that persistent connection. And then the Boundary client, again, just connects through this HCP worker to get to the egress worker to get to the final destination, which is your host resource. And again, this all happens in the background. It's not like the user or the admin has to manually do this every time. It just, when a connection formed, this is all the things that occur in the background. So how exactly do you configure this? Well, it's actually pretty simple. If you have not deployed Boundary before or configured these workers before, it's basically these VMs, these Linux VMs that reside in your network. And there's typically a configuration file that determines the behavior of that worker. So it looks something like this. It's very short, but you would, for multi-hop sessions, what you would do to define what's ingress and what's egress, all you do is give it a tag, right? So for this ingress worker, I'm giving it a tag called upstream. You can give it whatever name you want. It doesn't really matter. So in this case, in this example, I'm just saying this is, given a tag with upstream. And then my egress worker, I'm going to give it another tag called downstream. And I'm also going to tell this egress worker how to connect to my ingress worker there's that initial upstream parameter, and there's the IP address, the internal IP address of the ingress worker, right? So that's how the egress worker knows that when it comes up, it knows how to connect and form that persistent connection. Okay, so that's how the connection between the workers are made. So how does the Boundary client know where to traverse, how to connect, and how to get proxied through these workers? Well, the admin, on a per target basis, the admin would typically just add these filters or just indicate how to reach the specific target. So when in our UI, there's a way for you to go in and, or the admin would go in and add these tags, and it would say, hey, if you're gonna try to connect to this target A, use this ingress worker. And any worker that has this upstream tag would be the ingress worker, so look for that. And then any worker that has this tag downstream would be the egress worker, so look for that. So it sends this information to the client, and the client goes out and connects using this information based on those tags. That's really it's pretty simple. That's how it works in the backend, right? And again, as a user, the user doesn't know the difference. They just say, "Hey, connect me to target A," and then everything gets automatically done for them as their session gets created. So in the end, this provides organizations with a lot more flexibility to deploy Boundary in these, very diverse and potentially complex networks that have really strict networking policies. And this also reduces risk because you can address more of your end resources, right? You can use Boundaries in more places without having to compromise your topology, without having to change your network security policies and use public IP addresses and any of that stuff. You can keep it as is and continue and use Boundary to securely access your network resources. Okay, so here's a quick demo. I'm going to play this and give you a quick demo of what it looks like. Hi, I'm going to show a quick demo of HCP Boundary with multi-hop sessions, which is a feature coming on the latest Boundary.12 GA release. So here's my setup. I have two Azure networks, a public network and a private network. The private network only has outbound access. What I'm going to do is deploy a Boundary worker in my public network. It's going to have a public IP and it's going to also have a private IP. And then I'm also going to deploy another worker in my private network, and it's going to have a private IP, and the private network, again, only has outbound access. Each of the workers will have a specific tag, one called upstream and one called downstream. Then once the workers are set up, I'll create a target that points to our host that we want to connect to, and then we'll go end to end from a user's point of view to see how it works from a Boundary client trying to connect to that target and how it gets proxied through the ingress worker and egress worker. All right, so let's take a look at our workers. So I'm going to look at my first worker here. Let's take a look at the config file. So in the config file, it's pretty basic. Nothing new here for you to see if you're familiar with this already, but basically we're just saying this worker is using this public IP address. This is going to be my ingress worker. So I'm going to also tag it with the tag upstream. And everything else should be pretty much the same and something you're already familiar with if you've done this before. All right, so let's go ahead and exit out of here. And we'll start the worker. All right, so then we have this auth registration request. So we'll take this here and we'll copy it into our Boundary UI. So I'll go into workers, click new, and add the registration here, and my first worker is added. So we'll go ahead and refresh, and there it is. All right, so we have our first worker added to Boundary. Now we're going to go to our other worker and take a look at the file as well. So this is going to be a little bit different from before because what we're doing is chaining this other worker to my first worker. So you'll see an upstream field here that tells this worker to connect to the upstream worker at this IP address, which is the IP address of my first worker up here. So everything else is pretty much the same. I'm just adding a tag called downstream on this worker as well. So we'll go ahead and exit out of here and also start this worker. Same thing, we'll register this worker with Boundary. So now I have both workers registered with Boundary. So let's take a look at our target now and try to set up our target so we can connect in. So I'm going to go to my org, go to my project, and let's create a new target. And I'm going to call it Ubuntu multi-hop target. And then we're just going to select the generic TCP. We'll set the target address for my host. So let's take a look at that here. So I'm in Azure. Here is the host we're trying to connect to. And it's going to have this private IP address of 10.6.1.5. We'll add that here. Use port 22 since we're going to do SSH. And then down here is where we set those filters so that it matches our workers. So for our ingress filter, we want to make sure it connects to the worker that has the upstream tag. For the egress filter, we'll make sure that it uses the other worker that is tagged with the name downstream. All right, then we'll click Save. All right, so everything is now configured. The last step is just to connect in as a remote user. So I'm going to log on to my desktop UI. And here I can see that target that I created earlier. So let's go ahead and connect. And it says there is a connection. So we'll go ahead and attempt to SSH in. So I have another terminal, and we'll just go ahead and SSH with the port that was given to us. And there we go. It's going to ask to log in. And there it is. We are logged all the way into the Azure host that we had earlier. All right, so that's the multi-hop sessions demo. Thanks again for watching. Okay, cool. So hopefully that was insightful on how all the things I talked about. Hi, I'm going to show a quick demo. Let me move to the next slide here. All right, so next thing I'm going to talk about is assigned SSH certificate injection. Again, I'll give you a brief background on how it works with SSH credentials today or prior to the Boundary.12 release. So if you want to connect as a Boundary client to this Linux host, and you are using SSH to connect to that Linux host, again, you'll request to that target. These credentials could be stored inside a Boundary, or you can use Vault as a centralized secrets management platform. So in this example, I show Vault as the credential storage for your secrets. So Boundary, on behalf of the user, will go out and grab those credentials, or in this case, SSH password and SSH keys, and it will send it down to the Boundary worker, and then it will send it into the Linux host and inject it into the session on behalf of the user. So the user experiences a passwordless connection. They don't have to log in. It's already logged in. It's already logging them into this Linux host for them, right? So that's basically how it works today with credential injections and SSH keys and SSH passwords. So one of the challenges is that a lot of customers, some use SSH keys and passwords, but a lot of them may prefer to use SSH certificates. So prior to the .12 release, we didn't support SSH certificates. And just kind of give a rundown of the differences between SSH keys and SSH signed certificates is that with SSH keys, each user needs to have a unique set of public and private keys. So this makes it pretty challenging for some centralized admin or centralized team that's managing these credentials at high scale to have to accommodate for many hosts and many users. Becomes really challenging to maintain, leads to key sprawl. It makes it really hard to rotate, which is why it's often not rotated at all. And these credentials tend to be long-lived, and if they are long-lived, there's a potential that it falls into the wrong hands and get used by unauthorized and unintended users. So with SSH keys, with SSH signed certificates, it makes it a lot easier for organizations with large number of hosts and users because you only have to copy the certificate authority's public key into the host, not a unique public and private key for every user and host like you would with SSH keys, right? So it's just a single public key for every host. It's a lot simpler to manage. There's less key sprawl or very limited key sprawl. And these credentials that are given to each user, it's short-lived and it would expire. So a lot easier and secure for many organizations. So we're happy to say that in the latest Boundary.12 release, we support signed SSH credentials or signed SSH certificates. Boundary also supports the injection of these signed SSH credentials as well. So credential injection is a feature we mentioned it a couple of times already, but just to reiterate, credential injection is the ability for us to inject the credentials directly into the session on behalf of the user, so that when the user actually gets to and logs onto the machine, it's already logged them on, right? So they have a passwordless experience, and they don't have to manage or handle or even ever see the credentials themselves. Boundary will use Vault as the certificate authority in this when we support this, or since we support it already, we will use Vault as a CA. There's lots of endpoints that Vault provides for Boundary to make that communication between Vault and Boundary to request these certificates or these signed certificates. So here's how it works now. When an admin, or if you want to use this, the first step is for the admin to generate or enable the Vault SSH certificate authority engine on Vault. So when they enable it, these Vault CA private keys and Vault CA public keys get automatically generated. The admin simply has to take that Vault CA public key and copy it into their host, then configure the host to trust this CA. And then from at that point on out, when a user wants to connect to a certain target, the Boundary controller would then create a private and public key pair and then send the public key to Vault. Vault will respond with a signed certificate. Boundary will send all the needed information down to the Boundary worker, right? So the signed certificate, the username, and the Boundary public key, pass it all the way through to the Linux host to establish that session. And the Boundary client, the user, would just connect all the way through to the Linux host and get right onto that host without having to log in or anything else like that, right? So it's much more secure, as you can see. And then when it's done, these public keys or the session will expire and the signed cert will also expire. All right, so hopefully that's a good overview for you folks. I'm going to pass it back to Xinglu to talk about approval workflows.
Yeah, thanks, Van. So I'm going to play a demo on our new approvals workflow integration with Indent. And this is available for OSS and HCP. Hey everyone, today I'm giving a quick demo of our new Indent integration. So today in Boundary, if a user wants access to a target, the user needs to be given a specific role to access that target. And these roles and groups need to be set up beforehand. So what if you wanted to give user just-in-time access? For example, if there's a support incident going on and that user needs privileged access somewhere, and you want to give them access through some manager that approves it. Well, with the Indent integration, you can do that. So what you can do with Indent is, for example, if you have a service like Slack or ServiceNow, a user can use that service to request access to a specific Boundary group or role. Indent will take that request from Slack after it's been approved by the manager and update Okta's managed groups. Boundary currently already pulls information from Okta's managed groups and will update the groups and the role accordingly. So to give you a demo of that, I'm going to first show the environment that I'm in. So right now I'm logged in as the admin, and I can see I have multiple roles, and in the Canada, multiple orgs, and in the Canada org, I have 3 projects. And what I'll be accessing today is going to be inside the Ontario project. So Ontario will have 3 targets. If I go to my Okta admin portal, I can see that I have multiple groups set up, and these will correspond to theoretical groups in Boundary. So if I now go to Boundary and I try to log in, this is using an account that doesn't really have access to anything. So right now I can see there's no targets for me to access in here. What I can do as a user is I can go to Slack. Let me pull up Slack. And in Slack, I can request access by using the Slack bot down here. So I can go to my shortcut, or I can type /access and hit request access. Here, there's a pop-up asking what do I need to access. So because I'm a specific user, I can actually limit the amount of groups I can see. If you recall from the Okta dashboard, there was about 10 different groups, but as this specific Xinglu user, I can only access the groups labeled can dash. So I'm going to request access for Ontario, give it a reason, and hit submit. So indent tells me that this access request was received, and if I go back to the dashboard, if I go to an admin account, so this is a different, this is a Slack account of a theoretical admin, and this admin can see that Xinglu requested access for Canada, Ontario for fun. And similarly, if you go to indent's dashboard and you go to petitions, you can see that there's a new petition by my Xinglu Slack user, and I can open that. I can see that it's waiting for review, and I can give it access. So I can do it either through here or through Slack as the admin. So I will give it permission for 30 minutes and submit the review. So now me as the Slack user has been given the grant, and I will go back to Boundary and try to log out and log back in to see what I see. So I'm going to hit sign out. If I sign back in, I'm just going to wait for the Okta to load. Okay, so now I'm signed in and I can see 3 targets, and these are only within the project of Ontario. And to show what that looks like, I'm going to log in with, if I go to the admin UI and I try to log in with that same account, because I'm not an admin user, I can only access Canada. You'll see that everything on the left-hand panel is missing. But if I click Canada, I can see Ontario, and I can see the information for Ontario. But if I go to something like Quebec, I can't see all that information because I still don't have access to Quebec. So now let's say the admin wants to revoke this access. I'm just going to close this. I'm going to go back to my admin page. I can click revoke. And if the user comes back, so you do need to sign out and sign back in again for Okta to update. Oops. And now you can see that there are no targets available. So this was the quick demo of Indent. Right now, they're still pretty early stage product, and there's a lot more features coming from them. There are things that you can do with other integrations. For example, I was shown a approvals bot that, for example, if you're on a service call for support and you have a request come in, that bot will automatically give you access if you request for access. Thank you for watching. Oops, close that by accident. Just to answer the question in Q&A, click this. Can Indent integrate with more providers than just Okta? I believe right now Indent only works with Okta and GCP. And I think they're building out their integrations for more in the future. I do also want to point out a second way that these can, sorry, just checking my screen. I do also want to point out a second way that this can be done, this kind of approvals workflow, and that's through Boundary's API. And that's just using some external service that you want to use. For example, I've seen an integration with ServiceNow where they wrote their own API workflow to work with Boundary to do the specific triggers and allow users access to specific resources at a time. Slide. Hey everyone, today I'm giving a quick demo of... Okay. And the final topic I want to cover today is addresses on targets. And again, this is also available for both OSS and HCP Boundary. So today, if you want to have, oops, let me open this. If you want to create a new target and you don't have anything in Boundary yet, you have to go through these steps. So first, as you have your control plane up and running, you need to create your organization, and then you need to create your project so that you can have targets and hosts. With that, you need to have a host catalog, and then you have a host set, and then you need to have your specific host, which is your IP address. And then you would create a target, and then you would link that host set to the target. So clearly, there's a lot of steps in setting up a target, especially if you don't even have any orgs or projects ready. And this has given a lot of complexity to a lot of users and a lot of confusion on how to navigate this kind of resource domain model. So in 0.12, we wanted to really streamline that process and get rid of that the whole dependency on host catalogs, host sets, and hosts. That means, if I can just get to it, all you need is your org, your project, and your target. And that's why we have allowed users to put addresses straight on targets. So that means when you are setting up a new target, you just need the target, you can get your IP address, and you get your port number, and you put it directly on the target. And in the UI, this is what it would look like. This is what it does look like, because this has already come out in Boundary 0.12. And just to be clear, we're not getting rid of host catalogs, host sets, and hosts at all. Those are still all in Boundary. We just have removed the dependency on it so that you can create a target without needing to connect any kind of host sets or catalogs. Stop going. And overall, we hope that this new feature improves the experience in Boundary and allows users to have a faster time to value. For any additional resources, we have them linked, and I believe these will be sent in the chat. And if you're watching this recording on YouTube, this should be in the description, as well as an email that's being sent out to participants. And this goes over the complete 0.12 GA blog, which includes the release notes. There are a few other improvements that we made in 0.12, such as authenticating without needing to provide the auth method ID. There's the getting started tutorials, there are multi-hop session tutorials, and the general Boundary documentation. Thank you for attending this webinar, and I think we can stick around for a few minutes to answer any more questions, so you can place those in the Q&A.
Yeah, so Xinglu, one question is for the target addresses and targets, is it IP only, or can you put fully qualified domain names in there as well?
I'm not too sure about that. I believe it's IP only today. It's a single IP endpoint.
Yeah, that's a good question. Something I've been meaning to try out or look into, but I haven't. I don't know myself either. So let us get back to you on this. If you're able to provide your information, email, we can respond back with an answer for you. Another question is, can I put multiple IPs in one target, or will it be restricted only to one IP, and I still need to create different targets for the other different hosts?
Yeah, so it will be only one IP and one port per target. If you want different hosts, you can either have different targets, or again, you can go and use the host sets and host catalogs. With host set, you can technically have multiple IP addresses per target.
Yeah, and to add on to that, the idea is to have new users that want to just try it out with a single IP, and as you get more comfortable and as you scale, that's why we still have the host sets there, where you would have multiple hosts in there, and then manage it, have a better way of managing multiple hosts tied to a single target. So yes, two different paths for a novice person and someone who's an expert, or someone who's using something at higher scale, I should say. Any other questions out there? Lots of good questions. I think that those are good ones that can help others. I think there was a good one earlier about using Terraform as well. So to reiterate is that, someone was asking if we use Terraform to do a lot of these things besides instead of having to, click on a bunch of buttons to configure stuff. And so and the answer is, as Xinglu has already pointed out, is yes, you can use Terraform for a lot of things, for most things. And so, we were obviously using point and click just to kind of demonstrate some of these functionalities so you can kind of see it in action. But yeah, you can absolutely use Terraform to configure a lot of things. There are some exceptions, as Xinglu pointed out, which is, I believe, if you were to, register the worker, that would have to be done manually. But lots of other things are available to be automated by Terraform. Any other questions?
Okay, it looks like there aren't any more questions. So thank you everyone who did, engage and ask some questions, and thank you Van and Xinglu for this presentation. It was very good. And to everyone who is still on, just as a reminder, we'll make this recording available after processing, which is typically within a few business days. So you'll get an email with the actual recording. And it will also be posted on the HashiCorp YouTube channel. So you should be able to find it there as well. So thanks again, everyone, and have a great day.
Thank you.
Thank you. Bye.